Welcome to TrendProof. Today's briefing connects three space system developments: a new national policy for launch and reentry, NOAA's latest space weather outlook.
The first development is a new national space transportation policy issued by the White House on August 20th. The policy treats access to, from, and within space as a national and economic security interest. Its scope is broader than a single rocket program. It covers launch and reentry ranges, scheduling, infrastructure, spectrum, airspace coordination, industrial capacity, and future transportation to the Moon and Mars. The memorandum sets a long-range benchmark. By 2030, U.S. launch and reentry ranges are to grow to support more than 1,000 launches and reentries each year. That is a stated policy objective, not a guarantee that the number will be reached. The document also directs agencies to develop federal range scheduling criteria within 180 days, with the stated aim of making better use of range resources for commercial users while meeting government needs. Why do range schedules matter? A launch site is more than a pad. It relies on controlled airspace, tracking, communications, safety teams, recovery planning, weather constraints, and coordination with other users. As launch activity rises, scheduling becomes an operational problem as well as a business problem. The policy directs several agencies to evaluate launch and reentry infrastructure and to consider potential additional facilities. It also calls for work on integrating space launch and reentry management into airspace and traffic control modernization. The document places NASA, transportation, commerce, defense, homeland security, and other agencies in the same implementation picture. It calls for a plan around the U.S. space transportation industrial base and asks agencies to consider workforce, supply chains, infrastructure resilience, and commercial access. The policy says federal users should favor commercial transportation services when they can meet government needs, subject to public safety and national security requirements. There are important limits to keep in mind. The memorandum directs future work, reports, evaluations, and criteria. It does not by itself build a new launch site, approve a particular mission, or settle every permitting question. Several deadlines run from 90 to 240 days after the memorandum. For viewers tracking this story, the next concrete signs will be published scheduling criteria, agency implementation plans, and any announced infrastructure decisions. The second development is the operating environment above Earth. NOAA's Space Weather Prediction Center issued its 3-day forecast at 12:05 UTC on August 21st. The forecast says no G1 or minor geomagnetic storms are expected from August 21st through the 23rd. It also says no significant transient or recurrent solar wind features are forecast for that period. That is the steady part of the outlook. But NOAA also reports that radio blackouts reaching the R1 level were observed during the previous 24 hours, with the largest noted on August 20th at 16:11 UTC. For the 3-day forecast window, NOAA assigns a 40% chance of R1 to R2, or minor to moderate, radio blackouts on each day, and a 10% chance of an R3 or stronger radio blackout. These NOAA scale labels describe potential impacts, not a prediction that every system will fail. R1 and R2 conditions can affect high-frequency radio communication on the sunlit side of Earth and can degrade certain low-frequency navigation signals for brief intervals. The practical effect depends on the timing, the technology, the region, and how operators are configured. Aviation, maritime users, amateur radio operators, satellite services, power grid managers, and researchers all monitor these forecasts for different reasons. This is why space weather forecasting belongs in a conversation about space transportation. A launch window depends on many conditions, including weather close to the ground, range safety, vehicle readiness, and the environment a spacecraft will enter. Space weather is not the only factor, and the NOAA forecast does not announce a launch cancellation or a specific threat to a mission. It is one operational layer in a much larger picture. The public takeaway is simple. The current forecast does not call for a G1 or greater geomagnetic storm, but NOAA sees a chance of radio blackout conditions over the next 3 days. NOAA updates the product twice a day, so anyone who relies on the information should use the current official forecast rather than a social media summary or an older graphic. The third development is about what spacecraft can measure back on Earth. NASA Earthdata reports that NISAR L-band data have been released, expanding the record of surface changes observed from orbit. NASA describes the new data products as a way for researchers to observe changes across Earth's surface. The significance is not a single dramatic image. It is the ability to compare measurements over time and identify where conditions are changing. Radar-based Earth observation can be valuable because it can measure characteristics of the surface in ways that complement optical imagery. Depending on the product and the scientific workflow, researchers may use these records to study deformation, vegetation, water, ice, land change, and the effects of hazards. The data themselves are not an automatic conclusion. They must be processed, compared with other measurements, and interpreted by specialists. But expanding an open record gives researchers and public agencies another evidence stream to examine. NASA's Earthdata site also highlights research on ways to gauge snow depth using ISAT-2 observations. The recent article says a study examined the accuracy of satellite data for estimating snow depth and found that ISAT-2 can provide reliable estimates. That matters because snow is not simply a scenic layer on a landscape. In many watersheds, it is a form of stored water. Better information about snow depth can support research and planning around seasonal water availability, runoff, and drought conditions. It is important not to overstate these developments. A new data release does not mean every local question has been solved, and a research result about snow depth estimation does not replace local forecasting or ground observations. The value is in building a more detailed, repeatable picture. Researchers can compare periods, combine multiple sensors, test findings, and make their methods more transparent. The connection back to the policy story is practical. More launches and more spacecraft do not automatically create public value. Data has to be calibrated, accessible, understandable, and used responsibly. The connection back to the space weather story is equally practical. Satellites operate in a real environment. Their operators must account for the sun, orbital conditions, communications, and the needs of people who rely on the information produced from space. Today's report uses official NASA archival data visualizations only as related Earth observation context. They are not presented as NISAR mission footage, and they do not show a current local event. The labels make that distinction clear. This is a useful habit whenever you watch a space or science video. Ask whether a picture is direct event footage, an archival visualization, a simulation, or an illustrative scene. The answer changes what the picture can prove. So what should viewers watch next? First, watch for agency implementation documents from the new space transportation policy. The most useful updates will name responsible agencies, timelines, published criteria, and concrete actions, rather than repeating a headline. Second, watch NOAA's latest space weather forecast if you need operational information. The product is updated every 12 hours, and the forecast window changes. Third, watch how research groups use new Earth observation data, including whether methods, limitations, and uncertainty are explained clearly. There is a shared lesson across all three developments. Space policy is not just about launches. It is also about traffic management, safety, communications, research, and the information people use on the ground. Strong claims should be tied to a named source, a date, and a clear distinction between an objective, a forecast, a measurement, and a confirmed event. For the policy story, an objective is the administration's stated goal to expand range capacity by 2030. For the NOAA story, a forecast is an estimate of likely space weather conditions across a stated time window. For the NASA stories, a measurement is a recorded observation that researchers can interpret alongside other evidence. Keeping these categories separate makes a briefing more useful and helps prevent a policy goal, a forecast probability, or a data visualization from being mistaken for a completed outcome. There is also a practical accountability question. When agencies announce a plan, the public can look for the next published milestone. When a forecast changes, the source should show the time it was issued. When a scientific data product is released, the documentation should explain what it measures, where its limitations are, and how it can be accessed. Those details are less dramatic than a headline, but they are the details that allow viewers to verify a claim. In the months ahead, the national policy will produce deadlines for scheduling criteria, infrastructure assessments, security reports, and planning around launch and reentry. The present NOAA outlook will be refreshed several times before any policy deadline arrives. NASA's Earth observation records will continue to grow as researchers compare changing conditions across seasons and years. The common thread is a space system that includes what happens at a launch site, what happens above Earth, and what happens when data reaches the people who use it. That is the TrendProof standard for this report. Use official sources, identify the date, label archival or illustrative visuals, and distinguish confirmed information from future targets and forecasts.
Those are the verified updates: a new transportation policy, a watch on radio blackout risk, and expanding tools for observing change on Earth.